So this is a good example of what we call priming. Priming is giving you the expectations that we want you to feel. So, the amazing Randy, was he priming you? By picking up the thing and only talking when he turned it on. Yeah. Or by looking around at people, making eye contact with people. Was he pretending to see? He was priming you to be able to see. There's a really good TED Talk about it's a blind guy who was this entrepreneur who graduated with multiple degrees from lots of different things. He doesn't really tell you he's blind until about 3/4 of the way through the TED Talk. And the reason he doesn't tell you he's blind is because his eyes look perfectly normal, and he's looking around, and he's pretending that he can see. He's pacing back and forth. All things you wouldn't expect a blind person to do. And because he's doing all these normal people behaviors, you even think that he's blind. No. And so, but then somebody comes out with his stick, and he puts on his glasses, and he stands there looking off at something that isn't where the crowd is, and then all of a sudden you have this whoosh. Oh yeah, he's blind. And so, this idea of priming is another word for making assumptions. It's another word for biasing. The difference is can I prime you to feel a certain way, one way or the other? Yeah. And the way I prime you is I give you information. So let's look at the brain and see how this works. Okay? Because our world is full of noise. Can somebody tell me what noise is? Okay, so noise can be sound. What's the difference between noise and music? I like noise, though. Noise is pleasurable. Like if you're at the beach and listening to the waves, that's considered noise. Yeah. So, but how is that different than noise? People create it? Well, what about birdsong? A lot of Mozart was him whistling back and forth with his damn bird. He had a magpie that he just would whistle back and forth with. And if you listen to a lot of Mozart music, it's a little call response because his little stupid Tweety bird would Tweety back at him. Look it up. Okay. Okay, so noise has no pattern. Some people find noise extremely relaxing. It doesn't. The waves don't come in at exactly the same interval. Waves are caused by wind. The wind causes the waves, and the wind blows. So if anybody that was ever out here surfs, when you go surfing, every wave isn't exactly the same. Every wave is different. And the waves come in sets. You have small waves, and the waves depending on where the swell is, they slowly get bigger. And you can tell the experienced surfers because they'll wait on what looks like a good wave, because right behind it's an even bigger wave. Or then you're like trying to be cool and not, if you don't surf, and you wait for the next wave, and then there's no more waves after the big one, and all the surfers took the big one. Okay, and that's because it does have a rhythm, but the rhythm is not very predictable. That's why a lot of people get hurt surfing. Okay, yeah. Oh, sorry. You teach your reflexes. Sorry, your hand goes up. Okay, so but noise means it doesn't have a pattern. So if I turn on white noise is static sound. There's no pattern to it. By making white noise, it's actually very relaxing. Because with just noise, playing music backwards, it creates noise. We can't really follow the pattern to it until you've listened to it multiple times. It doesn't seem to make sense. When you play music forward, it makes more sense. because you can hear the pattern. I like jazz, and so a lot of jazz has chord progression. And if you listen to a lot of the music, you start hearing the chords. And when you hear the chords, like I played this song before, I don't want to play it because I don't want to have to stop and start the recording again. But if, like the ornithology song, and you can play the whole song, and I can start seeing the chords in my head because I played that. I had an audition that I had to play that damn song for, and then improvise for two cycles of the song, and then come back and start playing the song again. I came back one measure ahead. And they all laughed. Sure. Yeah. But what determines music versus noise is that sort of pattern. The pattern makes music into music. If people do, everybody remember the stomp performances where the people bang on trash cans and stuff? It starts out with sounding like a bunch of noise, but what starts to develop as it goes? A rhythm. And that rhythm immediately becomes I love that kind of stuff. But some people would say, oh, that's just noise. It's because they don't, like I played death metal earlier for you guys, Sepultura. Some people, oh, that's noise. Well, if you have that right mentality, that's not noise, it speaks to your soul. And you might need to get some help. But aside from that, I like all sorts of music. I really don't like country music anymore because of the lynching song, Texas Justice. I'll play that for you a little bit later in the semester when we talk about racism, and it's just a horrible, horrible, horrible song, but people sing it at bars and it pisses me off. Anyway, I don't like skinhead music either, so I can say that. So, yeah, I don't like that. It bothers me. But I also don't like a lot of look at all the cool stuff that I have music. But, okay. So, doesn't mean I don't listen to it. It just means I don't like it. So, the idea of noise is that the world is noise. What is the noise that the world is? Zoom in a little bit here. I'm going to do that. What is the noise of the world? Let's go pretty deep now. What is it? The noise of the world is electrical activity. Every single neuron in your brain produces electrical activity. Constantly. Every single neuron is constantly producing electrical activity. What happens if it stops sending electrical signals? It dies. Your body gets rid of it. That's what Alzheimer's is. The neurons get clogged with these plaques and tangles of proteins. And if these plaques and tangles of proteins block the neuron from functioning, the cell goes fine and stops feeding it. And that cell stops being fed. All the cells it connects to down the pipe lower their levels of threshold. And when they lower their electrical activity, cells downstream also get debilitated. And just to show you this, let me pause this. Okay, so the reason I wanted to show you that video is because every time there is a spike of electrical activity, what's released? Transmitter. So if I increase the frequency, what happens? More. If I decrease the frequency, if I add GABA, what happens? Less transmitter. So a lot of the current research is actually, there's two basic people. There's the structuralists who are trying to find all the synapses. What do the functionalists do? Not just the behavior. The neuroscientists, there's functional neuroscientists. What are we looking at? Why do I have that little cat? Yeah, we're focused, the structuralist, I'm going to draw this over here. The functionalists are looking at the brain activity. The functionalists are the ones that are looking at the MRI, the fMRI. The little brain that I had up here that was lighting up when I was wearing the headset, that is a functional MRI-ish. It's very, very crude. But it's literally, I can see where the function in my brain is coming from. The better the electrode cap, the better we can see your brain functioning. Okay. Easy, hard, overwhelming? It's getting better, right? That's the whole idea, is getting repetitive, because the way you remember something and the way you learn something is you do it multiple times. And every time we teach you something, I'm adding you a little bit more information. The key thing that for today is, well, your brain is full of noise. But what do these little things called primes do? Yeah. It gives you a pattern. As soon as I write the words up, you can hear them. Because it tells your auditory cortex what sounds mean what. Or it's like with the politicians going with songs. Their mouth is moving. If it doesn't quite line up correctly, we use the word, it's a badly dubbed film. Do you ever watch Hercules Comes to America? Arnold Schwarzenegger's first movie. It's pretty funny because he couldn't speak English yet, so it was very badly dubbed. So he's like, well, I think I can pick that up. And it's like this completely random voice. Mel Gibson in Mad Max, the original, is dubbed in. It's not his voice. It's him down. It's like this. And it's not Mel Gibson's voice at all. Anyway, so because as soon as you prime something, it gives a pattern. And does our human brain like noise? No. Noise can be relaxing. Noise can help you sleep. And in fact, you need this nice absence of noise. If you have an absence of noise, what happens? Your brain waves synchronize. Your brain waves synchronize. So if you have too much noise, that's beta activity, which I showed you on the thing, or gamma activity, lots of movement. But if I was able to sit and meditate and get my brain waves to synchronize, once my brain waves synchronize, I can go to sleep, because synchronous means no noise. Well, my wife and I have a ceiling fan above our bed, and the day we moved in, we turned it on. I don't think it runs constantly, unless we're not home and I shut the light switch off, because I'm energy conscious and I love the planet, so I shut all the lights off when I leave the house. But as soon as we're like ready to go to sleep, the light switch goes on and that fan's on. Well, 10 years ago possibly, X years ago, we turned it on, it went pop. No ceiling fan, it died. Both of us are trying to go to sleep. What's missing? The noise from the damn ceiling fan. We couldn't sleep. A lot of y'all's parents got you hooked on Mozart as a kid. Back in the early 90s, they started saying that playing Mozart makes your kid more intelligent. Turns out it doesn't. But a lot of kids couldn't sleep because their Mozart generators broke. Or if you have like a clock, my son has his ceiling fan. It runs constantly. I can't stand it because it goes tick, 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 tick. And so ours was doing that, and I took a little bit of yo-yo string wax and put it around the edge of where the little ball and socket thing is, so it doesn't tick, 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 tick anymore. Because why would that tick, 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 tick? It kept priming my auditory cortex to listen to it. Like we talked about when you're a parent, what are you primed to listen to? Rustle, rustle, rustle. Not even just a rustle, rustle, rustle. You're like, your auditory cortex is just ready to go, and it's attached directly to your cerebellum. Wake up. Time to get up now. That's why I get up right at 4 o'clock. The coffee maker goes click when it turns on. My auditory cortex is sitting here waiting for that click. Okay, because that primes me to tell me what to think. So we're going to go through the brain, take a little break, and then we're going to run through the brain and then start talking about the main focus of today is what our emotions, which are all primes. All right. It is a blessing for school. I really highly recommend. Okay. So I want to go through this. Pretty quickly. But so I just randomly grabbed 2 pictures of the brain off of Google Images. It doesn't really matter. All the brains, is everybody's brain the same? Yes. Very similar. What's different is the connectome. Every single one of you has a completely different connectome, but we have the same brain. So the major, like everybody sees back here. Everybody does. What if you're blind? You actually still see back here, but you don't see with your eyes. You see with your touch. So like for people that are blind, well, it's too much information, but in order to see something, your brain calculates lines, edges, corners. And that's how we see things. That's when something is blurry. You can't find the edge of it. So Massimo used to have t-shirts, what are you staring at? That were all fuzzy. Yeah, we saw those. But so we look for edges. So when you're blind, you don't look for edges. But how do you find edges? Touch. When you put your hand on a flat surface, it activates the part of your brain that registers horizontal surfaces. So the person, can they see their apartment? Yeah, they can in their head. But wait, does that Neil Harbison guy hear color? He sees them. He perceives color. But his perception of color is, but he knows what color is. Anyway, so what is the part of your brain where you see? Occipital lobe. This is one of the left there. Okay, this is back here. Back here. That's your occipital lobe. Technically, you actually see right back here. This is the part of your brain where you actually see. What is the rest of this stuff then? You analyze what you see. Shapes. Names of things. That all goes this way. When you try to name an object, like yo-yo. Okay, I went looking for them this morning. I found them. And then I kept remembering to go look for them, then getting distracted by something and forgetting to look for them, and then remembering, and then as I'm walking out the door, I'm like, yo-yo-yos! So I remember. Okay, so then where things are relative to you goes up into the parietal. That's right up here. Okay, there's your parietal lobe. It's between, it actually goes all the way up to this big lump right here, the central figure. Okay? And so this whole area right here is where you feel your body. Yourself is located right here. There's yourself, kids. That's where your self is. If I anesthetize that part of the brain, what happens to you? You're not yourself. Kind of weird. Your recognition of the people you care about is right here. This is the left hemisphere, so what's on the other side is where you recognize right temporal parietal junction, if you care. Okay? So that's where you empathize with other people. So what's this part in the front then? This part is your frontal lobe. Oh, that's cool. Why did I do that? Cool. Anyway, I have no idea what just happened. Okay, so it's your frontal lobe. What does your frontal lobe do? Behavior. Behavior. That's where your motor neurons are. Your motor neurons, I will try to color in this pretty pink color, which represents the basic color of the brain itself. So that was relatively stupid, but that's okay. You get the idea. But this is your motor cortex. Every neuron here represents a twitch, a muscle. If Charles is trying to glue the electrodes back together this afternoon, depending on my daughter's feeling, she's at the doctor right now. But if he's trying to glue them, he needs very high motor control. His motor cortex is very detailed. Doing something like juggling or doing something like writing, that's a lot of motor cortex. A lot of tiny little muscle twitches in order to get something done. Has anyone ever watched like the surgery shows, like ER was the old one, but Grey's Anatomy, when they're doing like sewing neurons back together and stuff, or dissecting tumors out of dead people? Oh, that's another one, yeah. Those folks have an amazing dexterity, an amazing control over their motor cortex. Very conscious, very precise movements, because every neuron in here connects to a muscle fiber. But what about, so that's easy. So this part right here, which I'm going to color in yellow, this is whole side here. This is your prefrontal cortex. We didn't really talk about that yet. This prefrontal cortex is probably the most important part of human brain. It's really what separates us from most of the other creatures on the planet. Except maybe crows, we have one of the largest prefrontal cortexes. Crows have really big prefrontal cortexes too, which makes it very creepy, but not important. We'll talk about that later. Okay. The prefrontal cortex is where priming comes from. Prefrontal cortex has this really important job. Choice. How do you choose what to do? Why did I choose to take a drink of tea? Well, there's a lot of things going into this. One of the biggest things is that if I look over and see my teacup, what do? The visual information goes into my temporal lobe. My temporal lobe goes, that's a teacup. As soon as I say teacup, my hippocampus goes, today it's a double black tea. Yeah, extra bitter. Okay? And the black tea, my brain goes, my insula. On the inside of my temporal cortex goes, I know what black tea tastes like. It's extremely bitter, especially because I haven't had anything to eat yet today. Black tea on an empty stomach causes not ulcers. You gotta have a lot. It's tea and ulcers. Pansy. I can drink black coffee on an empty stomach. No, it causes nausea. The tannins in. Anybody ever have a big glass of orange juice on an empty stomach? Yeah. Don't eat an apple and orange juice on an empty stomach. It's guaranteed nausea. It's just the acid in there. Yeah. Well, stabbing them in the head would definitely change their aggressive personality. Tink, tink, tink. So we can actually, before we get to aggression, because we're going to go to emotions in like just a couple seconds, because emotions have a lot to do with choice. Okay, conscious choice comes from the cortex. So if I'm over here, and I look over and I see my teacup over there, my body does a escape check. Am I thirsty? And if I see my teacup and I'm thirsty, I notice it first. My thirst primes my choice. One day we were racing our bicycles in the velodrome. Velodrome's a circle bicycle track, highly entertaining. You ride around in circles for hours. Really silly, but it's awesome. Okay? So I forgot my water bottle. So when you're doing high amounts of electrical, physical activity, why do you need to drink a lot of water? Yeah, you breathe out a lot of moisture, a ridiculous amount of moisture. And you sweat out a lot of moisture. So you have to keep your muscles with the fluid in them, otherwise you start cramping up. And so I had cotton mouth. Have you ever had cotton mouth in here? You go to spit, it just sticks on your lip. Oh no, it's just not good. That means you're really severely dehydrated. And so every time I saw somebody with a thing of water, I'm like, I need water. So he was talking about it. What happened? Yeah, immediately your mouth starts getting dry, because what you're doing is your prefrontal cortex is listening to your parietal lobe, the dryness of your mouth. It's paying attention to the insula down inside. If you're not really thirsty, water can taste very bad. But if you're super thirsty, you'll drink tap. I drink tap anyway, but that's not important. You don't even notice how bad the tap water tastes if that thirst level is high. So underneath the cortex, there's these things called drives. And the drives come from an area called the hypothalamus. Right here. So it's underneath. So I'm going to draw it. It's right in the middle here, underneath. So these are two pieces, like this is the surface and then this is folded in half. So you can kind of see on here, there's the cerebellum. And you can see the cerebellum right back here. Okay, so it's right here. What's this stupid little gland right here we were talking about yesterday? There's your pituitary gland. And you notice the hypothalamus, if this is hypothalamus, that is the thalamus. Good. Okay, so I'm going to draw the thalamus right here. What's this shape right here? Right below it, in front of the cerebellum. Yep. Now the amygdala is actually in the temporal lobe over here. It's pretty dang close to the hypothalamus though. Pons. Yeah. Pituitary controls the hormones that cause the drive. Okay? So the pituitary gland is a feedback circuit. So when the pituitary gland connects to your blood system. Okay? So when blood flows through the pituitary gland, there's different levels. There's a chemical called aldosterone. And there's a chemical, let's see, I have to channel that lecture. Give me a second. Okay, so there's angiotensin, there's a bunch of hormones, which I can't remember right now, but if you ask me during chapter 7 in my physio class, I know them all. Angiotensin 2, vasopressin, antidiuretic hormone, they're all in there somewhere. Oh, I forgot about the thing. Okay, so when those hormones flow past the pituitary gland, they tell the hypothalamus, hey, your body is running low on water. Get thirsty. That thirst sends through the cortex to your prefrontal cortex and makes you look for water. It's actually an area in the hypothalamus called the lateral preoptic area, if you could. Okay? But this hypothalamus then says, hey, you're thirsty. Once you're not thirsty anymore, what does it do? It stops sending the signals looking for water. And this is actually a problem with kids. Kids do not drink enough water. But I'm not thirsty. It doesn't matter. I don't have to pee. It doesn't matter. Go squeeze out what you can because we don't want to stop in 15 minutes. But I don't have to pee. You don't have to pee when you have to. You pee when you need to. Kids' road trips. Highly entertaining. The reason is because if we lived based on our drives, we would be very much like a lot of the animals. Does dogs, do they care when they pee or poop? A little bit. They don't want to pee or poop inside, but when they go for a walk and they're allowed to, they'll just go. Cats are a lot more particular where they like to go. They like nice fresh sand to poop in. And it's really funny watching cats poop. Anyway, highly entertaining to me. It's a weird thing. But I got a great video of a cat pooping at the beach. The best sandbox in the world. Okay. And so, what are some other basic biological drives we can go through that are controlled by the hypothalamus? Hunger. What else? Okay, so depression is up here. So even though the biological drive's there, what happens? The prefrontal cortex can't tell the rest of the cortex to get on it. And as a result, you're hungry, but it's not that you don't want to eat, you can't get the energy to eat. And then this is the wonderful thing about your self-talk, your temporal lobe goes, stupid, why aren't you eating? And then your prefrontal cortex listens to the temporal lobe and says, but I really want to, but you're not. Oh, what's wrong with me? Welcome to spiraling of depression, ladies and gentlemen. And I make jokes with it, but it's very serious because your drives are still there, but the connection between the prefrontal cortex is where you choose the behaviors. When someone has depression, we'll talk about this later in the semester, you can't make a choice of which behavior to do. So what do? Not. You choose not to do something, and most people choose to sleep. But they can't sleep, but they just feel like they need to sleep, because sleeping is the easiest choice. It's the only choice that they seem that they can able to do. We had a friend of our family's that was very depressed, and he would sleep 16, 17 hours a day. He would come home for lunch remember when all the conspiracy people said that the government was reading all your emails 20 years ago? They were, and he was the guy writing the software where he wrote software, he went to Cornell and studied defense studies, but he wrote software that read emails. And it would flag emails that were subject in nature. And the computer intelligence would read the emails. There wasn't a person reading your emails. The computer was just kicking emails toward a person that seemed interesting. And it read metaphors and it meant understanding, and that's what he did for a living. He wrote computer code to read your email. And then they had to rename it as the Patriot Act so that people didn't get upset by it. Whatever. Okay. But he worked really hard, but he also, like one weekend he had a weekend off where he had no responsibilities. He got a hotel room and spent the entire weekend away from his family sleeping because he just wanted to sleep all weekend. Yeah, okay. Finally, he got some help for his depression. But, so what other drives are here? Hunger. I wish hunger was perfect. But are there any fat coyotes? Well, are there a lot of cats? Yeah, rabbits. Oh yeah, well, the coyotes up there, even though they're healthy, they don't get obese. Our neighbor's dog is extremely obese. It's a big lab, and it comes waddling out. It can't even put its feet underneath it, so it stands out to the side. And why is the dog obese? It eats with the people. Its owners are also squishy. So, for domesticated dogs, they get obese. Coyotes do not get obese. They get well fed, and they will tear apart your house cat, but oftentimes, if they're not hungry, what do? They leave most of it behind for you to find. Whoopee! Okay. So, I love Roxy, a friend's cat. They live over on the hill over in Mount Helix. Okay, so, yeah. So the pituitary releases hormones that control the thyroid. Thyroid would be down here somewhere, right? So if the pituitary doesn't get the feedback of the thyroxine, then the pituitary doesn't release the hormones. It's all feedback. Hormones are all feedback. And so that's the reason that the pituitary is so important, is because it helps balance. And this is the key of your drives. I'm going to write this under here. balance. Your hypothalamus controls balance. This is what controls drive. So when you are out of balance, that causes motivation. That's supposed to cause motivation. When you're out of homeostasis, when you're out of balance. So if your fluid levels are perfectly ideal, are you thirsty? No. But as soon as your fluid levels tip a little bit low, then you are motivated, you increase your probability of drinking until you drink enough. And the physiological responses for drinking are a little bit behind. By the time you're thirsty, you're dehydrated. By the time you drank too much water, you feel bloated. And that's why it's better, like what we were talking about before, is if you just get to a steady state of drinking water all day, you don't get dehydrated, and you don't have to pee all the time. It becomes a set point. It's the same thing with your calories. So we've been doing the, so that's the other part. No, I'm talking about what's called a set point. A set point is an average. Your body has a typical hydration level that it likes to stay at. It has a typical blood sugar that it likes to stay at. But that set point is based on this average. So for me, for a long time when I was in college, my goal was to get as big as I could. And that's, if anybody looked at that on the YouTube channel, I dumped these online. There's one that I'm throwing the weight. Oops, not that one. But back when I was in college, that one. This is a really old video. It's not working anymore. In this video, aside from the short shorts, which I like my short shorts, that's me weighing about probably 265. And you can actually see my stomach through my shirt. I was very big and muscly. Not so much anymore. You can still see my stomach through my shirt, but yeah. Okay. My friend called it my flab. Not ab. Your flab. Yeah. Don't worry. Okay, but so back then, I had to eat 5,000 to 7,000 calories a day just to maintain my body weight. I had about 8% body fat for lifting 6 days a week, on the track every day of the week. Sundays we went for bike rides, took the day off. So why do I have to eat 5,000 to 7,000 calories a day? Well, because that's what my average, that's what my set point was. So right now, we're doing a calorie tracking thing. My wife and I are both doing this for the holidays. We're trying to do this for fun. I use this nutrition tracker app, and it keeps track of the number of calories and what nutrients I'm eating throughout the day. You just log all your foods into it. Like for today, I put a little bit of non-fat milk in my black tea so I didn't get nauseous. So I put a quarter cup of non-fat milk in my app. 9 calories for the tea, and then like 12 calories for a quarter cup of non-fat milk. But why am I keeping track of it? Data. Well, your set point becomes extremely subjective. If I were to just free eat whatever I wanted to, I would get up to probably 300 pounds. Because I like food. What kind of foods taste good? Processed foods. I love tortillas. I could eat tortillas every day, all day. But a tortilla is an excellent food delivery system, but if you're just munching on tortillas, it's a lot of calories. They just add a lot of calories if you're just snacking. Tortilla chips or potato. I really love potato chips. I try not to eat them at all, but they have these really thick crinkle cut ones from Trader Joe's. Man, those are good. But as opposed to just grabbing the bag and munching on them, what do? That's free eating. We don't do that. We have a food scale, and I'll put out a chunk on the food scale and measure the amount that I'm eating. And we do this because you have to be conscious of what your drives are. And when you like just a little tiny thing of nuts, it's 200 grams of nuts, that's like 350, 400 calories. And with cashews, just a small handful of cashews is 100 calories. And so by being conscious of it, and I'm not so obsessive about it. If you go to a restaurant, I order whatever I want. I'm not too obnoxiously obsessive about it because that becomes a disorder. But at the same time, if I listen to my hunger, my hypothalamus wants me to be back to 260 pounds. But how come my dad bod doesn't want me to be back to 260 pounds? Sadly, my average is 235 to 237. I want to be around 220, 215 to 220. But if I stop paying attention, what happens to my body weight? My hypothalamus is saying, you're starving yourself, gain some weight. And this is a big discussion we've had with my daughter because she'll go, well, I'm not hungry, and not eat for a day. Why is that bad? So your hypothalamus goes, holy crap, you're starving, pituitary gland, release chemical called leptin, increase the amount of fat storage. If you eat a very consistent diet, your body kind of figures it out. Anyone watch the Super Size Me? Yeah, he went and ate a bunch of junk food. Healthy guy, ate a bunch of junk food, got sick. Well, no kidding. Anybody who's traveled to a different country, what happens when you first get there? You get sick. Your body, the nutrients are different when you travel to different places. And the foods are different, and you get sick. My mother-in-law did a cleanse. She had ovarian cancer, and she went and did this health food cleansing thing in Spring Valley somewhere. And it's super healthy, super good foods. She was sick the entire time she was there because she was eating foods that she's not typically used to eating. And her poor system had no idea how to digest that. I mean, if you look at cultures where there's no obesity, they eat the same food all the time. And as long as they're properly balanced nutrition, if you look in most of Mexico, the only really place you see obesity is where they eat American food. Because if you eat prototypical Mexican food, beans, rice, lean meats, and vegetables, every meal. And beans, rice, and a tortilla are a perfect protein. You really don't need anything else other than that. And you can subsist on that, plus some vegetables. Anyway, but the idea of trying to understand the hypothalamus, we can talk about all the other drives, but I really don't want to focus too much specifically on the drive. But there's also sex drives. There's sleep drives. Sleep is actually the #1 drive that controls your behavior. There's a chemical called PER and TIM, or proteins, produced in the hypothalamus. If you have too much TIM, you fall asleep. How do you get rid of TIM? Sleep. As you sleep, the enzymes go waka, 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 and eat TIM. The only cure for being tired is sleeping. Because when you sleep, your hypothalamus and your pons get together and say, oh. How do you know you've gotten enough sleep? We'll talk about this later. You actually don't feel tired. Wow. Brilliant. So when oversleeping means that you're not getting a good sleep. There's a big difference between, the easiest analogy for that is you get hammered one night and you go to sleep and you sleep for 12 hours, you get up and you feel like your tongue's dragging across the floor all day. The reason is you pretty much were inebriated most of the night and got about 2 hours of real sleep. Yeah, just because your eyes are closed and you're not responsive to the world doesn't mean you're sleeping. Yeah. I analogize it to airplane sleep. Airplane sleep is the worst. Just enough to not be conscious, but not enough to actually get you sleep. So it kind of feels like you didn't move for 2 hours, and the person next to you was watching you drool for an hour, but you're not actually. So when we talk about the brain activity, then you can actually see what makes real sleep versus pseudo-sleep. And one of the biggest things that affects your long-term health is your sleep hygiene, is your biological set point for sleep. you have to have good sleep in order to live a long time. I sleep 7 to 8 hours every night. Well, no, some people need more sleep. For me, I have done I've measured everything. That's what I do. And my friend who's a nutritionist has this cool ring that she wears, and it tracks her heart rate and it tracks her sleep. She charges it every 2 days, and it connects to her phone. It looks just like my wedding ring. And it tracks her sleep, and it tracks her heart rate, measures her blood pressure, and all sorts of neat stuff. Yeah, if you have a smartwatch, I'm probably going to get one of those coming up soon because I want to get a better count of my calories when I'm exercising. But yeah. Yeah, but that's...
Well, it's also based on how you get tracking my heart rate.
Yeah.
With my anxiety or my depression, if I stop breathing, it's like, hey idiot, breathe.
Yeah, because a lot of people, especially taking a test,
Yeah.
I'm serious, a lot of people taking a test go like this.
Yeah. So it's actually tracking your heart rate, your blood pressure, everything.
But once you become mindful, that's the goal of it. Once you become conscious, you can turn that off because you can control that consciously. But a lot of it is controlled down here. Is it conscious in your brain? No. So when your stupid hypothalamus releases a chemical called cortisol. It's actually ACTH. ACTH. Kidney releases. We'll talk about that later. It's not good. But when your hypothalamus decides to get stressed about something, it screws everything up. But you can actually know when you're releasing this ACTHRF, acetylcholine releasing hormone. You can know it because you can feel it if you become mindful of how your body works. But that's why the watch tells you, because then the watch teaches you, oh, this means that's what it feels. The same thing as I'm able to control the cube with my thinking. Same exact thing, except I like to think about this part of the brain, the thalamus and lower. You have no control over it. But you do have, how do you have control over your pons? How do you have control over your medulla? You do. So when we drove through the mountains on the day after Christmas, it took us 21 hours to get there. Out of those 21 hours, I drove for 19 of those 21 hours. Left at 3:30 straight. We got out of the car twice. Three times. Okay? And I was no problem. And the reason I was able to do that is because I had to. And was I tired? Yeah, but there's that part of that adrenaline rush of like, oh, this is really crappy now. Okay, now it's fun because it's so awful. That's my personality. My buddy and I go on bike rides that turn into really death marches, and it's like you get done and you're like almost dead. You're like, that was awesome. Okay. My daughter's getting drugs. Well, she's been sick and she's without the doctor, so she's getting drugs. So that means she has a bronchitis. Yeah. Let's wait to that after when we get to that section because I have a whole chunk of class based on it. So you have to wait and not sleep until then. Okay. So, and the reason I want to get through the next part so the reason why this is so important, and the reason I keep saying this is so important is that you are not in direct control of this part of your brain, but you are in control of you are your frontal lobe. That's where your choices come from. And so your choices can change the way that your lower brain works. That's why choosing to regulate, where's your water? Okay, there. Choosing to regulate the amount of water that you're drinking every day, does that change your body's set point? Choosing to make sure you get enough sleep, does that change your set point? Yeah, and this is why sometimes collecting data really does help with trying to make choices because it gives your prefrontal cortex more information. Can it also backfire? Can people become extremely anorexic and crazy with these apps? Yes, and that's also a negative effect of it because if you become so if your amygdala is causing you to constantly worry, and you're choosing things because of the anxiety, not because of trying to achieve a health goal, those are different reasons, similar sounding choices, but the underlying reason for those choices is bigger than just the choice itself. So, yeah. Sometimes. You can't say every single person has a different pattern. But when you are, if someone does have symptoms of depression, it's called hypersomnia. Lincoln's not going to be in purple either. Okay. We always get these, our neighbors are the flakiest neighbors ever. We love them dearly if they're listening to the podcast. But my son's at school. Who's picking me up today? The neighbors. And the neighbors like completely forget that they're in charge of carpool every Thursday. Every Thursday. So who's picking us up today? I know it's Tuesday, but I'm not teaching the afternoons for the next 2 weeks, so I'm picking up the carpool. But because I have forgotten Mabel once because I got a text saying no Mabel, and I said, oh, no Mabel, and we left Mabel at school. And then I got a phone call from middle school saying, where are you? She didn't say, hi, this is Mabel. It's just, where are you? She's not good phone skills. And I'm like, oh, your mom said you weren't picking you up. She goes, that was yesterday. I look at my text, yesterday. Oh, my bad. We're coming to get you right now, and I bought her a burrito. Because nothing says I'm sorry like a bean and cheese burrito. So, okay. So, sorry. Okay. So I'm not perfect in carpool either. Okay, so now, when we talk about this whole idea of drives, our hypothalamus controls these drives. These drives influence behavior. So I'm going to zoom back out again, and they influence behavior. Their drives are one way of priming you. They're one way of priming you to do things. The other way of priming you to do things are your emotions. So, oh, I didn't mean to do that. Are your emotions. Okay? So, your emotions come from this part of your brain called the limbic system. Your emotions are, we'll talk about what they are, but the limbic system is basically your thalamus, your hippocampus, your hypothalamus, and your good old-fashioned amygdala. Now, if you take more advanced classes, there's a bunch of other parts. There's a part called the fornix, there's a part called the cingulate gyrus. So the big rod that you were sticking in your head to make people stop being aggressive, that's the cingulate gyrus. Okay? There's a part of your brain where aggressiveness comes from. And it's actually kind of funny, but it's in the center of the brain. I'm just going to roll. It's this bumpy part right here. Okay, and that part is where attack and escape behaviors come from. Can I talk about second one today? Okay. Yeah. So the amygdala is. Oh, sorry. The cingulate gyrus is directly connected to the amygdala. Some people attack when they get afraid. Cats attack when they get afraid. Dogs, however, do what when they're afraid? Fart. Oh, I think it's fart. That's a horrible one. Boo! Oh! Yeah. Skunks do. Yes, okay. Yeah, so like a skunk gets afraid. It stands on its hind feet and sticks its butt up in the air saying, back off, buddy. What does a chicken do when it's afraid? It just activates that and then flaps and runs. I miss our chickens. I love chickens. But so a human does not have a predictable response when it is scared or challenged or afraid. Some humans, I freeze. Like the possum. I won't pull the image up, but anybody seen Fabulous Mr. Fox? His friend that he walks out with is a possum, and the bad guy shows up, and the possum's like, The fox is like, oh, come on, snap out of it. Anyway, so you gotta watch that over the weekend. It's absolutely awesome. So, but the singular gyrus, if you have an aggressive singular gyrus, what's your response when something aggressive, attack? And some people are like that. Some kids are like that. You can see them on the playground. My wife deals with them. She knows everyone by name. Kids are being kids on the playground. One kid just decks the other kid. And like, oh, sorry. We call that impulse control. Because who controls that cortex? I didn't mean that here. Who controls that singular gyrus? The frontal lobe. And kids that don't have a very well-developed frontal lobe react instinctually. It's not instinct, but they react on their biology. And can they learn to not react on their biology? Yes, but they have to learn. First, I had to learn the names of the colors you give them. So you have to learn how to react. Kids with autism can't react to people's faces very well. So what do they have to do? Learn. You have to learn how to react to people's faces. A lot of kids with autism, if they take drama classes, really helps them. Because then, when they get in a situation they don't know what to do, they put on a role. They act a role. They have to consciously learn how to act. But do we all learn how to act? Yeah. Every so often I have a student who's been homeschooled their entire high school life, and they get to college and they're like, whoa! And it's just like, okay, let's learn how to act. You're homeschooled. So, you're doing just fine now. Excellent. Okay? But the idea is that when your limbic system basically are your emotions. These are it's really hard to really understand this, and that's why I showed you the pictures of the connectome video. This limbic system is that center part where all the neurons are going back and forth across the entire brain. Every single neuron in your brain goes through these parts. Every single neuron in your brain goes through these parts. And of course that's a lie because not every single one, but the metaphor is really important. It's a general statement. Because all of your senses, except smell, go directly to your thalamus. All of your senses, except smell, go directly to your thalamus. What does your hippocampus do? Memories. It records, all of these sensory information. It records them all. So that if that same sensory pattern comes through again, the hippocampus goes, yeah, you've seen that. The hypothalamus is telling you how you should react hormonally to it. That's why if I see this cup, what's really funny is that during the semester, if this is sitting here, what will I do 10 times during class? I don't try to drink out of it because as soon as I touch it, the sensory feedback from my parietal lobe feeds back to my prefrontal cortex saying, wrong choice. Because the feedback is what allows it to stop or start. And so I always have some sort of coffee or tea mug up here. And it's just because ever since I first started teaching in 1993, I used to go to Mary's over by San Diego State and get a cup of coffee and a poppy seed muffin. Oh, joyous. And I would eat my poppy seed muffin and talk to some of my friends before class, and with my mug of coffee, I would go and sit and have class with my mug of coffee. And ever since my first year teaching, that has become such a ritual. If I don't have something to drink up here, I'm kind of panicky. And often if we take a break, I'll run and get some. I always have a coffee cup or two in my office. Sometimes they're growing stuff, which is not good when you grab the wrong one. Okay, sorry. So, if I say grab the wrong mug, some of you went like this. Why'd you do that? Ooh. Okay, say that again. Your emotions immediately predict the outcome of taking a sip of an old cup of something. And so it produces the emotion disgust. This disgust means, spit it out. It's really funny how disgust works. Little kids don't really have much disgust. The only thing that really disgusts little kids are bitter tastes. Little babies will make a yuck face for sour, but then they'll and then they go, and then keep munching on it because they like the taste, but they get the sour face. But things that are bitter, like if you try to give a baby a wheatgrass shot, they're like this, and they make this, or raw broccoli also for babies is terrible. Not babies. Make sure they have teeth before you feed them raw broccoli. What's the problem with raw broccoli? It's really hard to emulsify enough to chomp down to get into your digestive system. You really have to chomp on it or really soak that bad dog in some ranch. Okay, because once you get enough, it's hard to emulsify little chunks because the chunks just break up. So when you try to swallow it, it hits that soft palate in the back of your throat, and that tickles that soft palate, which means your brain says it's not ready to swallow yet. Did anybody ever took a swig of carrot juice? So next time you're actually ask if you can taste the carrot juice at whatever smoothie place you go to. Carrot juice triggers that response because what should be in your back of your throat when you have a piece of carrot? Chunks. But when you drink, solids. But when you drink carrot juice, you still get a tickle in the back of your throat as if there's solids there. There isn't, but your brain goes, well, there should be. It's kind of fun. I like carrot juice. Celery juice, or V8. If you're expecting fruit punch and you get a shot of V8 instead. Why does that make your brain go, whoa? The expectation doesn't match the actual outcome. So your emotions produce a prediction. This is bad. So this is the key. Emotions take your senses. Your emotions take all of your senses together and predict pre-consciously what's going to happen. So what would happy be? Happy is an emotion, but no. Yeah. Well, it should mean that there's no problem. So technically, happiness is not an emotion, it's just a state. And this is the big thing, is that one of the things that the book says that I really don't agree with is that excitement is an emotion. Don't like that. That's a biological state, not an emotion. Can you be excited happy and excited sad? Yeah. Well, yeah, think about what excitement means. Your physiological arousal. So if something really bad happens, you're physiologically really aroused, but then really sad at the same time. We use the word hysterical. That's an excited sad. Versus an excited happy is that little happy dance that we all do. Okay? So I'm going to write sadness here. I'm going to write a better word over by happy, which is a really important thing. This is a dangerous thing. Satisfying. Something that is satisfying. There's a million memes of satisfying things. On Instagram, if you type satisfying, there's a bunch of people cutting wax with knives or crushing things in presses or just random crap. Yes, it is very satisfying. What does that mean? I don't know, but you watch it and go, my son, for Christmas, I got him a fart cup. Oh, it's a highly entertaining thing if you're anal expulsive, and we'll talk about that later in the semester. But it's basically a little plastic cup filled with this gel, and you push your hand into it, and it goes. And by changing the angle and the force, and you can make all sorts of different flatulent noises with it. My daughter has tried to kill it 2 or 3 times. She actually threw it on the ground and stomped on it with her sandy beach feet after coming over the beach yesterday. And it now actually makes better sounds now that she has done that. So she is evidently adding sand really does move. Never mind. Okay. But it's funny because why does it create happiness? Why does it create joy? Because my son and I are both adolescent males, and it's funny. Soon he'll be 18, 5 years. Aww. And he'll be no longer adolescent. I'll be a giant dork. I'm already a giant dork. But he'll be bigger than me soon. Yeah, then I just am a giant dork in the neighborhood riding a recumbent around the block. Awesome. Okay, moving on. So, but what is joy? But it's joy. But what does it mean, though, in the context? But it's more than happy. It's like agape. It means love, but it's more than just love. It's like, So it has a joy is that what we call intrinsic happiness. It's happiness because of being happy. It's not happiness because if you got a shiny object. It's happiness for being. Okay? And but again, when you are feeling happy, what emotional state are you in? Has anybody ever been sad happy? Yeah, when my mother-in-law passed away, she did one of those. She had major cancer and it spread everywhere, and then she had the morphine thing, and because she was, let's put this delicately, a little bit overweight. What happened to the length of time it took her to pass away from removing the feeding tube? A long time. She lived about 2 months or so after, and eventually, because she was completely non-responsive, they took out the water tube. Because she said, I don't want to feel thirsty. That's one of her little things. But because she had enough adipose tissue and because she was getting liquids, she lived for 2 months as, just kind of lying there slowly breathing less. Yeah. So when she passed away, there was this great sense of sadness, but also this sense of happiness. She's not suffering anymore. We're not suffering anymore. Then all of a sudden there's guilt. What's guilt? Well, it's not. We didn't cause her cancer. But the fact that you're feeling happy that she's finally dead, oh no. Emotions are really complicated things. And did anybody ever feel the waves of this? By the way, guilt is the same as fear. Fear is a pretty strong emotion. Fear is the amygdala telling your cortex to stop. Guilt is fear. People that don't have any fear generally don't have any guilt. Is that good or bad? Or a superhero. Supervillain, superhero. They're really close. That's it. Okay? Because what makes one good or bad? The perceived intentions that they have. We see peaceful coexistence. Okay. Well, so there's actually a disorder called mania, where the person has such a strong sense of joy and power that they actually start becoming psychotic because they can't sleep, because they have this intense feeling of constant satisfaction. They don't need to sleep. Well, bipolar is part of it. Mania can be a part of some people's bipolar. And so, but you can also feel depressed, but depression can cause sadness. Depression generally removes joy, which increases the probability of sadness. And so it's a really hard thing to try to figure these out. It was so easy 20 years ago when all we did was look at your face. Is there a happy face? Okay, so yes, you can learn to make emotional faces. But what's interesting is that if you have someone watch them smile, you can tell the difference between a fake smile and a real smile. And the reason is because all the subtle little muscles on your face when you really smile, like if you have to pose for photographs, how do you do it? Well, we can, what's real and what's not? It's a hard question. But we can look at people's faces and pretty quickly generally tell if they're telling the truth or not. Some people are much better at it than others. Some people are very good at looking at someone, they look them in the eyes, and they can tell whether the person's lying or genuinely happy or genuinely sad. The way to fake it is just think of something funny and laugh. And if you think of something funny and genuinely laugh, your face automatically makes that facial expression. Notice, so your facial expressions are stored in your frontal lobe. Has anybody ever seen someone with a Bell's palsy? Where one side of your face gets completely paralyzed? Stephen, what was his last name? Warwick. One of my students. He was Gay Steve on campus. Because, well, his dad didn't know he was out, but everybody else did. So he was Stephen Juarez at home, but he was very flamboyantly homosexual. But his dad was in denial. Juarez, last name. His dad was from Mexico, didn't understand. Anyway, so Steve got a Bell's palsy. And it was funny because he's in my class, and every time he'd blink, he'd do this. And his eye would roll up in weirdness. I'm like, do it again. Do it again. Do it again. He's like, stop it. And his eye would never close. It would just relax and stay halfway open. And one side of his face is all flat, yeah. Well, whenever he coughed or sneezed, he had to put his hand over his eye because if you ever sneeze with your eyes open, the pressure to go behind your eye hurts. You can feel it. You're not going to sneeze his eyeball out. That would be cool, but no. Okay. I don't know. But if I could draw better, could I make a disgust face? Anybody making a face, ugh, you got that. Can I make a sad face? So wait a second. You have parts of your brain in your occipital lobe that look for what? Facial expressions. And in your parietal lobe, occipital lobe looks for the facial expressions. The parietal lobe immediately starts to feel what other people are feeling. Babies are really good at this. If you're nervous, what does your baby start to do? Start looking nervous. If you're making a nervous face, the baby's like, oh, I'm uneasy. Something's wrong. Because they spend a lot of time staring at the faces. Okay? What's a fear face? Okay, I'll make a little frowny fear face. Yeah. Let me delete that and make a little frowny. And anger, how do I change fear into anger? All I'm doing is drawing a couple little dots and a line on the screen, but I can really communicate emotions very quickly with these. Do they work all over the world? Yes. Some cultures are much better at hiding their facial expressions than others. In cultures that are very judgy, where you are judged a lot socially, people learn to control their face better. In cultures where you're not judged, that are much more communal and not so socially hierarchical, people don't really hide their faces whatsoever. And it's interesting, because each one of these is a prediction. Each one of these is a prediction. And excitement, I don't like excitement as an emotion, because excitement is your physiological arousal. Physiological arousal can happen with all of these. If you're very, there's a gentleman named Schachter and Singer who did a series of experiments. What they did is they got a shot of a cortisol, adrenaline. Okay? And so, well, they got a bunch of them, and when you'd walk into the room, you would get a shot. Okay? Part of it, you volunteer for the experiment, they pay you whatever. Half the people got shots of adrenaline, half the people got shots of saline. Do you know which one you got? No. Controlled experiment. They had people watch a video. One group of subjects watched a funny video. One group of subjects watched a sad video. One group of subjects watched something that was scary. One group of subjects watched some sort of action-adventure-y thing. Then afterwards, they gave the students surveys. How do you think this was on a scale of 1 to 10? How was it funny, sad, whatever? Whenever the people who got the adrenaline, how did they rate the experience? Say louder. More. Whatever it was more. So the hypothalamus and the pituitary gland, right now. Okay, the hypothalamus and the pituitary gland release the cortisol, but then if I gave an injection of cortisol, your pituitary gland goes, oh, we're releasing cortisol, which goes into the hypothalamus, which tells the thalamus that this is important. So they're all connected together. Your body is connected to this limbic system. Your body is connected to these emotions. So one of the hypotheses that we talked about with the video gaming, if the video game causes a lot of adrenaline and the child has anger, what's going to happen? It's going to elevate the child's anger. If the video game doesn't really cause adrenaline, is it going to make the child more aggressive? If the video game doesn't change adrenaline, then the child's aggressiveness is going to stay what it was at the baseline. So yes, some childs are more aggressive than other children. Some childs, English. But if you have a kid that is very aggressive, and he's playing a video game that stimulates a lot of adrenaline, what's going to happen? He's going to be higher probability of angry outbursts. So this is what's interesting when trying to do this experiment. We're going to start measuring people's cortisol levels naturally, before and after playing certain video games. And when we do that, we can see, does the video game really stimulate their body to become more responsive? Has anybody seen the VR Ninja game? Pretty cool. Okay, the thing about that is it becomes extremely competitive because what are you doing in order to, you basically hold two virtual lightsabers, and as in the VR goggles, things are flying at you, and you're Fruit Ninja basically. You can play that on your phone. It's 3D real-life fish Fruit Ninja. Or Wii sports shopping thing. We always play that up in the mountain. Okay, but if it stimulates a lot of adrenaline and you get a huge adrenaline response, what if you hate it? You'll never ever play it again. But if you enjoy it, how does that enjoyable deal if you have the adrenaline? It gets so much better. This is why, like games like Fortnite, they set up as a ramping game. Ramping game means there's some games that are like continuous gameplay. Like my son's been playing Destiny. A bunch of his friends abandoned Fortnite and started playing Destiny because it was free. And Destiny didn't really have a point. I mean, yes, there's missions, but each mission is pretty much, I'm going to go find a bunch of robot, alien, cyborg things and move on to the next robot, alien, cyborg thing. And every level it gets a little bit harder. I have no idea. I get bored. I don't know. I get bored and I walk away. But I drive my car around tracks. Yeah, I guess not very exciting. Anyway, so the second thing is that Fortnite, it starts out with everybody's fend for all, and it's a Hunger Games game, where it goes down to one person left at the end. And every time it gets more stressful because they make the playing arena smaller and smaller and smaller. And so the game is extremely well designed to stimulate that adrenaline. That game became from nothing to the most popular video game almost of all time in a couple months. Because what did people do? They didn't just play it, they started obsessing about it. And the EA games made a fortune selling little up things that really don't help you play. They don't make your game, like, does this help you in any way? My son plays as a pug. all sorts of clothes and backpacks, and my son has a lizard sitting on the back, and it's like, and his pitchfork thing to break stuff is a giant lollipop. Like, yeah, I spent $12 on that lollipop. Like, what? Never giving you gift cards again for your Christmas. Yeah. Okay. It wouldn't load on here. It's a video game. It's a first-person shooter, a third-person shooter video game? Third-person shooter video game. You follow your little character around and you try to kill people in order to survive. And you go, and as you kill people to survive, you get their stuff, and the more stuff you get, the likely you are to survive. You get bigger guns and better guns. And at the end, it's in a big giant world, and then the world shrinks. Until the end, it's literally just two people trying to kill each other before the storm kills them. That's it. And it's really gnarly. I'm serious. If you think about it, we're training our kids to be terrorists extremely well. Think about it. No, it's good. It's good for you. Go outside. It's beautiful out. Okay, so well, that's what I tell my son. It's like, if you spent as much time playing during the school week, there's no screen time during the school week until Friday afternoon, and then on the weekends he can get more screen time by going outside and exercising. I'm like, if you spent as much time on the Xbox as you did shooting hoops, you'd be the top player on your team. He's like, no, I won't, because he doesn't understand is what makes you good at stuff? Practice. And it's like he's pretty good at the Xbox stuff because he loves to play on it. And all of his friends play on it, as opposed to getting into the neighborhood and playing, which in our neighborhood is probably not a bad thing because someone was killed with a wrench at the 7-Eleven near our house. Yeah, okay. But I got his wallet, so it's okay. Now. Okay. It was a bicycle part that he actually beat him with. My son looked at me and was like, hey! I wouldn't hit anybody with a bicycle part. It's sacrilegious. Sure. Right. So her memory would get... So in most of the research with that, they've done it the opposite way. So they give you what's called a beta blocker. If anybody here with high blood pressure, sometimes you have to take a beta blocker, which blocks the effect of cortisol. Yeah, and then so when you take a beta blocker, what happens with your emotional levels? They stay flat. In other words, when you get angry, you get mad, but you don't get pissed off. When you get sad, you feel sad, but you're not crying and hysterical. So it levels out the swing. For some people, like there's an adolescent conduct disorder for teens that can't control their rage, they give them a beta blocker. Yeah, some of them, I don't know all the drug names, but yeah, but so when you take one of those, it allows the person to express without explosion. So I don't know the other way. The other problem is a lot of times what chemo does is, remember that connectome? If you're under very high doses for chemo, the connectome starts to fall apart. You get neuropathy and... Okay, that's good. Is it messing with your skin? Okay. Yeah, I think that years ago there was a TV commercials for Nissan for adrenalinitis. Have you ever seen that? The dog's like running at him, and Chomp, he's looking at it going, hi doggy. So, again, that's a little bit more specific than I can understand and answer. But if we think about it in the big global picture, is that do the emotions still exist? Are you still producing fear? Yeah, you still produce anger, fear, sadness, happiness, I still believe it, and disgust. But at the same time, is the swing wouldn't be as much there. And I think when you're older, do you rely on the adrenaline or do you rely on your consciousness in order to feel? Your consciousness. As you get older, your cortisol responses change. You just have less adrenaline as you get older. People that have high adrenaline as they're older generally have heart problems. My father-in-law he has AFib, atrial fibrillation in his heart, because he was a Division I volleyball coach for 20 plus years. So what do you think his heart rate is doing on the side of the volleyball match every game? Spiking, followed by decrease, spiking, followed by decrease. And a lot of people that do CrossFit are having problems with their hearts. A lot of the major CrossFit craze of the last 10 years, a lot of the people are having very severe heart problems because CrossFit is pushing yourself to the point where you don't think you can and then stepping into it. It's not good for you. Yeah. The cortisol is a hormone. It's produced from your brain, but it's actually produced by your kidney. It's adrenaline. Okay, and so, so cortisol. Help me count. 3, 4, 5, 6, 7, 8, 9, fine? Okay, so that's cortisol. What's happening to my heart rate? Not skyrocketing, but it's high. Respiration? High. Okay. What's colors my face? Why? Blood pressure. If I had a headache and I did that? Yeah, I'd be out. So my muscles, what happens to my muscles? Pumped. Well, that's cortisol. So to get rid of cortisol, what do you have to do? So we used to do a thing called biathlon. Yeah. So if I do this, sorry. We used to do a sporting event called biathlon. You cross-country ski, and you shoot stuff. Cross-country ski, and you shoot stuff. It's really cool. And so we don't do it in California because they don't like you shooting stuff, and there's not much snow. So we're trying to do one with mountain bikes and bows and arrows, which you can do legally in California, San Diego. So as I'm trying to calm down, why is taking a long, slow breath help me calm down? So that's activating my medulla to tell it to stop producing cortisol. So when you're skiing, heart rate's high, you want to stop, and what if your heart rate's beating really fast, you're breathing hard, you're trying to shoot something? So a lot of the Olympic guys will sit down to shoot and go, and their heart rate goes from 120, 130, goes to 90. So right now my heart rate is going back down. My respirations seem to be calmed down a little bit. It's a little bit too high. But so then if you wait just a minute and train yourself to relax, what happens? Your amygdala stops firing. Your hypothalamus stops releasing ACTHRF, the chemical that tells the pituitary gland that tells the kidneys to release cortisol. So now that I'm not moving, my cortisol levels are going down. Everything's good. Was that exercise? No. Did I sweat? Teacher pits? Underboob? Classy. Mark, the guy at the gym, always gets a smiley face on his shirt. Anyway, one time he actually sweated a kettlebell shake in his shirt. That was very impressive. But 10 burpees, That's not exercise. That's stress. That's what stress is. That's all it is. Cortisol. So if you get pulled over by a police officer, guess what? Same exact thing. Same exact thing. Unless you happen to know the person. My friend Hank is a CHP officer, and he was right behind me because he lives where I dropped the kids off at school 2 or 3 years ago, and he hit the siren on me. Whoop! So I saw it was him. So I flipped him off and floored it in the minivan and took off. For a few people around, how did that ask about that minute? He just laughed and shakes his head. And he drove off the other way. But for a few minutes, those people around thought that, take that, copper! Never get me alive, see? Okay, so, racing the minivan, it's a peace guy. But, so, if you were to do that with 10 sets of 10, what would happen? So that's, once you do the first set of 10 is actually really hard. The second set of 10, much easier. Third, even easier. Fourth, you start noticing it in your shoulder. Fifth, you start getting winded, and it takes a little bit longer break between the next two because you start burning a lot of calories. Doing 10 burpees, you're not burning very many calories whatsoever because it's not exercise, it's just stress. There's a race that I really like to do, but I can't run. My foot doesn't work. Or I don't want to learn to run again after I fix my foot. No, I just can't run. Anyway, but it's called the Spartan race. I love those things. They're so cool. Basically, you go for a trail run, and periodically they make you do something stupid, like carry this 50-pound bag of rocks up the hill and down, or throw a spear. I can throw the spear. I taught my neighbor how to throw a javelin. So he can throw the spear. You have to do burpees. You miss the target on the spear, you do 30 burpees in the middle of a run. And then you have to try to run, and then carry the rocks up and down the hill. And if you drop the rocks, what do you have to do? Well, or you do 30 burpees. Oh. Anyway, so when you think about emotions, these things right here, what are they doing? What are they for? Why do we have them? They're priming you. They're having you make choices. Yeah. No. Don't die inside. My son and I make that joke a lot. I died inside a little bit, thanks. But what happens is that if something inside your system, for the women in here who have been pregnant, as soon as you're pregnant, you feel like the same self. No. All of a sudden, there's another batch of hormones that are growing, and all of a sudden, you start crying on the couch. What's wrong? I don't know. My wife would do this all the time. She got really pissed because I left one of these markers on the kitchen counter. She's yelling at me, and I'm like, which I shouldn't have done because then I got yelled at more for being condescending, but whatever. But it was one of those things that if the hormones change radically, your emotions change, but you're not thinking, because who should be in control of your emotions? Sort of. You should at least know why you're having them. You should be at least along for the ride. You should be somewhere in there whatsoever. I don't cry very much. I'm not a crier. But when our new psych hire that we have, Marissa Salazar, she's really great, and I was really happy. So during her 10-year review meeting, I was trying to tell her how proud we are of how well she's doing her first year. I totally teared up, and I couldn't talk. And my other 2 colleagues were laughing. They're just like, shut up. Because it never happens to me to get all choked up. But it was just a very emotional experience, and it was very positive and joyful, and I just got all choked up. The same thing as we were watching Parental Guidance. May see the movie Parental Guidance? Basically, grandparents go to try to take care of some young people's kids that are like you people. Anyway, and there's a scene at the end that's really emotional, and I'm sitting on the floor, I'm flying on the floor watching this, and I'm tearing up, and I'm all teary because of watching this. My son's looking at me going, Dude, Dad's crying. They've never seen me cry before. Kid's born, check, got that, no problem. Dad died, check, got that, no problem. Mom died, check. Well, mother-in-law died, no problem. Okay? But watching a stupid movie, so in order for you, this is actually a really big thing. In order for somebody to become really in touch with their emotions, what do you have to do? What is the key to becoming in touch with your emotions? You can't control them because they're pre-conscious. They're pre-conscious. It's like you can control being thirsty by making sure you drink enough water all the time. But that requires consciousness. Okay? My wife has a very stressful job. Being a principal of an elementary school is extremely stressful. She is very stressed a lot. So as a result, she knows that her stress is caused by the things in her job. It's not caused by any inadequacies or herself. Because she knows the cause of her stress, can she kind of turn it off when she's not at school? She's getting that. It's called detachment. A lot of doctors learn to do this. While they're with their patient, they care, they're really supportive. They step outside of that room. You need to be detached, because can you bring every patient home with you? No, that's why it's hard for me to become a clinical psychologist, is because I care too much. And when I say that, what I mean is like my TA was suffering from a depression two semesters ago, and like I would email her, hey, you okay? You worried? I was like, I'm worried about them. They become my little family people. And it's like, it's one of those things where if I did that with every patient that I had, what would happen? I would be done in a couple semesters. That would be it. I couldn't, because do you take on the symptoms of your patients if you empathize 100%? Yes. It's like when your kid is sick, you feel horrible. Like Ella, my daughter, she's annoying when she's sick, but she's got bronchitis. So she's like, I got drugs, which means that she does have bronchitis. We thought she did because she was feeling better, and then she played volleyball yesterday and felt like crap this morning. Ooh, I forgot to call her in the high school. Oh, she's good. Okay. Can someone remind me right after class in 5 minutes to call the high school and to tell them that she's not there? Yeah. They're nice. I talked to Linda. She's nice. Okay, so I know those people by first name. Anyway, so the idea of mindfulness is becoming conscious. You can't control your emotions. You should not try to control your emotions. Freud said if the more you suppress and try to control them, the stronger they can become, because it causes anxiety, and the stress causes cortisol, and this cortisol increases the intensity of the emotion, and you just tick-tock. Well, so by becoming conscious of the emotions, and this is actually the key for the whole semester, by becoming conscious of your unconscious processes, it's not that you try to control them. You got to learn from them. Your emotions have something to say. Your emotions have something to do. There's a reason why you're feeling disgusted by things. There's a reason why you're feeling satisfaction or joy. There's a reason why you're feeling sad or guilt or anger. That's helpful. Okay? There's a reason why these are occurring. And what if you have anxiety disorder and you have lots of guilt and fear all the time? We'll talk about this later in the semester. But what can you learn? Yeah, where is the genesis of this? Where is the reason for it? If you have a lot of guilt and fear, if there's a reason for it, that's where you have to learn from it, as opposed to it doesn't define you, it's just a part of you. And it's one of those things that when I was really young, I had a lot of social anxiety. I was very nervous around large groups of people. And as a result, I never pushed myself. I never really pushed myself to do well, because when you do well, what happens? They pay attention to you. So if you just do okay, nobody pays attention to you, and you fit in the middle, and everything's easy. And so, but in my senior year of high school, I got really good at track and field, and they started writing newspaper articles in the local newspaper about me and all this other stuff, and I realized, oh, crap. So I ended up just shaving my head, not all the way, but I used to have long hair, and I got a short haircut, and I just said, I'm just going to embrace it and just play this role for a while. And I pretty much have ever since. But as a young kid, I would always be very sad or feel guilty or feel just afraid of everything. And I said, yeah, screw it. So I learned that very early for me. And as soon as I came to San Diego State, I didn't try to fit in. By the way, it's really hard to date when you don't try to fit in. Moving on. Okay, but I wore a rope as a belt. Sometimes a little necktie as a belt. I saw kids doing that last summer. I started that. Okay, so the idea was that just because the emotions are present, they're pre-conscious behaviors, who's in control of your consciousness? Yourself. But can you just become mindful on your own? Can you just say, oh, I'm just going to do it myself? Not everybody. It's very hard. I had the help of Dr. Bronstein as a kid. She happened to be our neighbor, but she was also a clinical psychologist. And she's the one that really helped me get over this childhood anxiety. I had no idea I wanted to be a psychology teacher until, well, I didn't realize back then. I didn't realize I wanted to be pre-med until I took organic chemistry from this Korean professor. And he's up there going, ha, 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 ha. I'm like, what major can I get? No, chemistry, psychology. Organic chemistry is hard, especially if you don't understand the professor. Okay.